We're going to learn about angles of parallel lines. And really there's just a lot of vocabulary and definitions that we need to know before we can understand how to work with these things. So what I've drawn here is two parallel lines, here and here, and so far we don't have any angles, other than I guess an angle on the line of 180 degrees, but as soon as I take another line, let's just draw one here, and cut across these two lines, all of a sudden there's a whole pile of angles that form in here. This line that cuts across this other line is called a transversal. So that's the name that we give that line there that cuts across two parallel lines. It's called a transversal. And there's a few other vocabulary terms that we need to know. If I said this angle is A, and this angle is B, and this angle is C, and this angle is D, we would call those angles interior angles. And interior angles are angles inside of the two parallel lines. So A, B, C, and D, those would be interior angles because they are inside or between these two parallel lines. And remember, the transversal is a line that cuts across the two parallel lines here. So then we could look at some other angles out here. Let's say E, F, G, and H, and we would call these exterior angles. Because exterior angles are angles on the outside of the parallel lines. So far our vocabulary includes the transversal, the line that cuts across two parallel lines. We've got interior angles, which are the ones on the inside of the parallel lines, and we have exterior angles, which are the angles on the outside of the parallel lines. So let's actually start looking at some of these angles that are formed. Let's number them. So let's call this angle 1. No, let's call this A. Angle A, angle B, angle C, angle D, angle E, angle F, angle G, and angle H. There's all these angles that are in here. And there's probably a couple of identities that you know already from maybe some of your previous geometry courses. Let's look at A and B, angle A and angle B. Well, this is a straight line across here. So angle A and angle B are what we call supplementary angles. And supplementary means that they will add to 180 degrees. This arc across here is 180 degrees. It would be half of a circle. We know a full circle would be 360. So anytime you have two angles on a line, like A and B, those two would have to add to 180. And there's lots of those here. E and F would add to 180. You could look at F and H. F and H would add to 180. G and H would add to 180 because they're two angles on a line. So we know that angles on a line add to 180 degrees. A and B would add to 180. Now the other thing that we can or probably know already from geometry is opposite angles are equal. So if I look at angle G here and angle F, they're vertically opposite each other. These two angles right here. So angle G is going to equal angle F because they are what's called vertically opposite. And there's a whole pile of those here too. B and C would be equal. A and D would be equal. We've already talked about F and G being each equal. And E and H would be equal. So vertically opposite angles are equal. So these were two things that you probably knew before. If not, you know them now. Angles on a line add to 180, and vertically opposite angles are equal. So let's look at some of these other angles in here that you may not have noticed the relationship before in the past. Now looking at, oh, we lost our G here. There we go. Looking at our angles here, we can see that, let's take a look at angle D and angle H. We can see that these two angles appear to have the same measure. And indeed, if we had two parallel lines and we got a protractor out and measured this, we would see that angle H equals angle D. So we call these corresponding angles. Angle H and angle D are corresponding angles. Those are angles that are on the same side of this transversal, so they're both on the right side, that are in matching corners. So these two corners here match each other. Those must be equal if these are parallel lines that we're talking about. Now sometimes, let's just get a different colored pen here. Let's go with blue. Sometimes we can call this the F rule. So check this out. See, if we follow this transversal and these two parallel lines, this angle here and this angle here are always going to be equal. So here's kind of the situation that we've got. You can think of this corresponding angles as the F rule. So the angles here and here will be equal. Now there's other corresponding angles here as well. So other corresponding angles that we have here, so we've seen, we've done this one, H and D. Also, you could say F and B are corresponding. Oops, not D, B, I should say. F and B. So these would be matching corners that are on the same side of the transversal. So B and F. If we were doing our F rule thing, the F would be upside down because here's our two parallel lines, dot, dot. So the F is upside down. On this side, here's our corresponding angles here. Angle A, this one up here, is a matching corner to E. So A would equal E. And on the same side of the transversal, the matching angles here would be C and G. So those are corresponding angles. Angles on the same side of the transversal that are in matching corners, like B and F, are going to be equal when we have parallel lines. Another one here is alternate interior angles. So what that means is that the matching interior, so remember the interiors would be the ones on the inside here, so matching interior angles on opposite sides of the transversal. So here's our transversal. So matching interior angles on opposite sides, so that would have to be F and C, and those appear that they would be the same amount, and indeed they are. So angle F would equal angle C. F equals C. Those are called alternate interior angles, and it's a good name for them. Alternate means on opposite sides, interior on the inside. So angle F equals angle C. We have another alternate interior angle here. We have E and D. So angle E would equal angle D. Those are alternate interior angles. And then if we look, let's go back and look at C and F. If we kind of draw the situation here, this, that angle and that angle, this forms the letter Z. So sometimes this is referred to as the Z rule because these opposite or alternate interior angles will always be equal. So angle F will equal angle C, alternate interior angles, and same thing we can say about D and E. This would be a backwards Z if we did D and E. Let's look at another set of properties of parallel lines. There's alternate exterior angles. So this is similar to the other one, except instead of alternate interior, we're on the outside. So these would be angles like GH and AB. They're exterior angles. So matching exterior angles on opposite sides of the transversal are equal. So that would have to be G and B. They are exterior angles on opposite sides of the transversal. And they appear that they're equal, and they are. So angle G would equal angle B. And we have another one over here, A and H. They are exterior angles, A and H, on opposite sides of the transversal. Keep in mind these only work if these are parallel lines. Parallel lines. So we're only talking about parallel lines. If that's the case, then these angles would be equal. So alternate interior angles, matching exterior angles on the opposite sides of the transversal are equal. We'll look at one more. So interior angles, okay, so we're talking C, D, E, F, interior angles on the same side of the transversal. So here's our transversal. That must mean D and F will add to 180 degrees. So D plus F equals 180 degrees. And that makes sense. Say we were driving along this road and we hung a right here and we hung a right here. Now we're heading back in the opposite direction. So we've done a complete 180 degree turn. This way, now we're heading that way. So D and F would add to 180. Also E and C would add to 180 degrees. Go this way, turn left again, you've done 180 degrees. So this, if you want to see a letter for this one, if that's the way you like, this would be called the C rule. And so those angles in there would add to 180 degrees. Interior angles on the same side of the transversal adds to 180 degrees. Now let's do a couple examples. Okay, let's look at these first two questions here, and let's say that the question is, in these examples, are these two lines parallel? Well, looking at this first one here, I would have to say yes, they are, because these are alternate interior angles. They're matching angles on opposite sides of the transversal. So are these parallel? We would say yes. Alternate interior angles are equal. So that's one of our laws that prove that these two lines are parallel if the alternate interior angles are equal. So those two lines are definitely parallel. Let's look at this one. So we know this angle is 68, we know this angle is 105. Are these two lines parallel? Well, we don't really have any rule with these two angles, but we can figure out some of the other angles here. So if this is 105 degrees, I would know that this angle here must be 75 degrees, because angles on a line have to add to 180. And now what I have here is I have corresponding angles on the same side of the transversal here. So I have that F rule. These are corresponding angles, but are they equal? No, they're not. So these are not parallel lines. Since corresponding angles are not equal. So these are not parallel lines. Let's look at this example. So we've got two parallel lines here, and here's a transversal, a line that cuts across it. The question wants us to find three angles here: angle CDB, angle ADC, and angle ADE. Well, when when they use this measure, angle CDB, this notation here, what that means is we're going to start at C, so here's C, we're going to go to D, and then we're going to go to B. And so angle CDB, C to D to B would mean we've got this angle right here, CDB. So we got to find the measure of that angle. Oh, forgot to mention that these are parallel lines. So we know that these are parallel lines. Sometimes they put little arrows on them to show that they're parallel. So knowing that these are parallel lines, angle CDB, this angle must be the same as this one because this is alternate interior angles. That's that Z rule. So I would know that angle CDB is 35 degrees because of alternate interior angles. Alt interior angles. A little shortcut way of writing that. And what do we have to find next? Angle A to D to C. So A to D, I'm going to actually write 35 in here. So A to D to C, that must mean this angle up here. A to D to C. Well, hey, I know that this angle's 35 here, and this is an angle on a straight line, so these two must add to 180. So that would make that 145 degrees. Angles on a line I can write for my reason. And finally, they want A to D to E. That would be this one over here. Now I have a couple ways of doing that. I could say it's 35 because these are vertically opposite. Or I could say this one plus this one has to add to 180 because those are angles on a line. That would have to do a little bit of calculation, so I'm going to use the vertically opposite angles for my reason to say that that's going to be the same as 35. Vertically opposite to CDB, to angle CDB. Okay, so there we've shown, we found the angles that they've asked for using our properties of parallel lines. Now this question set up a little more of a formal proof here. We've got 4 lines, A, B, C, D, and it's telling us line A is parallel. That little 2 slash lines together means parallel. So line A is parallel to line B. So I'm going to put the little arrows on here so that I know we've been told that's given. We know that. Line A and line B are parallel. And they've just told us that angle 1 is equal to angle 3. So sometimes we can do this. We could do a little slash in here to show that these 2 angles are the same. So angle 1 equals angle 3. That was given. So those are the things that were given. We have to prove now that line C and line D are parallel. So we have to prove that these 2 lines are parallel, C and D. So when we set these things up, sometimes we'll do what's called a 2-column proof. We'll make a statement. Well, let's give us a little more room here. We'll make a statement. And then over here we'll have a reason. So when we're doing a proof, we've got to say some things, some logic here, some logical statements, and provide a reason for that. So let's see. We know that these are parallel lines, A and B. So hey, yeah, angle 1 here must be the same as angle 2 because these are corresponding angles. So I could say then that angle 1 must equal angle 2. That angle and that angle are the same because those are corresponding angles. So now I know that angle 2 is like a little dash mark here as well. Now look at this. We know that angle 1 is the same thing as angle 2, and angle 2 must equal angle 3. Because they're both equal to angle 1. We were told right at the beginning that angle 1 is angle 3, and if angle 1 is angle 2, then since both 2 and 3 equal 1, 2 and 3 must be equal. So we know angle 2 and angle 3 are equal, And that means that we can now say that line C is parallel to line D. So these two lines must be parallel because these are alternate exterior angles. And alternate exterior angles are, if they're equal, then we know that these are parallel lines. So here's a proof. Proofs are tricky. They take a bit of time to think out, and they're a bit of a puzzle to prove these things. But make some statements and make sure that you have a reason that you can justify for saying what you've said. So let's review then these properties of parallel lines. So we know that angles on a line have to add to 180 degrees. For example, we would know that A plus B must equal 180 degrees. Those two angles are angles on a line. We also know that vertically opposite angles are equal. So angle A must equal angle D because they're opposite angles. We know that corresponding angles, those are the matching angles on the same side of the transversal. So that must mean that they're equal. D equals angle H. This is the one that we call the F rule. D and H. Alternate interior angles. So matching interior angles on opposite sides of the transversal are equal. An example of that would be angle C equals angle F. And sometimes we call that the Z rule. And we learned about alternate exterior angles. So those are the matching exterior angles on opposite sides of the transversal. So one example of that is A equals H. And finally, we saw that interior angles on the same side of the transversal would have to add to 180 degrees. So D plus F equals 180 degrees. So those are some of the properties of the angles of parallel lines.